Imagine breathing air that has teeth, so cold that every single breath feels like swallowing needles. This isn't just a bad winter storm. This was life during an ice age, a world where extreme regional winters could see temperatures plunge to 40 degrees below zero.
Now, you probably have the classic picture in your head. Our ancestors huddled deep in a cave, wrapped in thick animal furs, gathered around the life-saving glow of a fire. It's a powerful image. And it's dangerously incomplete.
What if I told you that the most powerful furnace our ancestors ever used wasn't in a cave at all? What if it was inside their own bodies? Sure, fire and fur were critical, but they were never enough. To survive a world that was fundamentally hostile to their biology, our ancestors had to do something that sounds almost impossible. They had to trigger a cascade of biological adaptations, effectively hacking their own evolution. This is the story of how our bodies became the ultimate survival technology.
First, you have to understand the sheer insanity of the problem. Our species, Homo sapiens, was born in the warmth of Africa. Our bodies are, by design, built to lose heat, not retain it. So when major waves of our ancestors began migrating out of Africa around 70,000 years ago, they walked straight into a world for which they were completely unprepared. They were moving into the frigid landscapes of Ice Age Europe and Asia, and their biology was all wrong.
Fire, of course, changed the game. It gave them a precious circle of warmth in an endless world of cold. Later in the Paleolithic, sophisticated tailored clothing, stitched together with freshly invented bone needles, created a personal layer of insulation.
But think about the reality of it. A fire only warms you when you're right next to it. What happens when you have to go out and hunt? What happens when a blizzard seals you in your shelter for weeks on end? What happens when the last piece of firewood is gone? Fire and furs were external solutions to an internal problem. For true long-term survival, the human body itself had to change. It had to become more efficient. The pressure was on, and evolution needed a new blueprint for a cold-weather human. And it found one.
Living in Ice Age Eurasia for hundreds of thousands of years before we ever got there were our cousins, the Neanderthals. If our ancestors were the tropical model of human, the Neanderthals were arguably the Arctic-ready version. For decades, scientists have recognized them as a profoundly cold-adapted group of hominins.
Their very skeletons tell the story. They had wide, barrel-shaped chests and shorter limbs than the lankier Homo sapiens. That stocky build wasn't an accident. It's basic physics. It reduces the body's surface area relative to its volume, meaning you lose precious heat much more slowly. Their energy needs were staggering. Some studies estimate an active Neanderthal may have needed between 3,500 and 5,000 calories a day just to fuel a body that was constantly fighting off the cold. Even their faces show signs of adaptation. One leading hypothesis, though it's still debated, suggests their large, wide noses were better at warming and humidifying frigid, dry air before it hit their lungs.
Neanderthals weren't just surviving in the cold. They were biologically engineered for it. They were the original blueprint. And when our ancestors met them, they didn't just compete. They collaborated in the most intimate way possible. This is where our own story takes a wild turn. Inward. Our ancestors began to leverage a remarkable piece of biology hidden deep within their own bodies, an internal furnace called brown adipose tissue, or BAT.
You might know it as brown fat. Unlike the regular white fat that just stores energy, brown fat's primary job is to burn energy to produce heat. It's packed with mitochondria,
the tiny powerhouses in our cells, which is what gives it its distinct color. When triggered by cold, it goes into overdrive, literally burning calories to warm you from the inside out.
For a long time, it was thought that adults lost most of their brown fat as they grew up. We now know that's simply not true. We all retain it, and it's plausible that our Ice Age ancestors not only had more of it, but were also much better at activating it. We know from modern studies that prolonged, repeated exposure to cold can increase brown fat activity and even recruit more of it. This means that with every passing winter, our ancestors' bodies may have been getting better and better at firing up these internal furnaces. It was a dynamic, living adaptation. A fire in a cave could go out, but this biological furnace was always on, turning their high-fat diets into life-sustaining heat.
Activating brown fat was an incredible trick, but the most profound changes were happening at a much deeper level, inside our DNA. The relentless pressure of the Ice Age was a brutal filter, favoring any genetic mutation that offered even the slightest advantage in the cold. And this is where the story of our Neanderthal cousins comes roaring back. As modern humans and Neanderthals met and interbred, we didn't just share territory, we shared genes. Our ancestors were essentially downloading a genetic software update that had been beta tested for hundreds of thousands of years in the Ice Age. Genetic research has revealed that some of the DNA we inherited from Neanderthals influences traits related to our skin and hair. Other genetic clues are more complex. For instance, there's a gene known as FTO, which today is mostly studied for its strong links to obesity and body mass. Interestingly, some researchers have noted that certain variations of this gene, which might play a role in how our bodies manage energy and heat, appear more frequently in populations whose ancestors lived far from the tropics. The story is not simple, but the evidence strongly suggests we borrowed survival code. It was a biological hack, a shortcut that helped us adapt to a world that should have been unlivable. But what if, in the most extreme conditions, these adaptations still weren't enough? This leads us to the most bizarre and controversial theory of all. In a cave in Spain known as Cima de los Huesos, the Pit of Bones, scientists found a mass grave of hominins dating back over 400,000 years. When they examined the bones, they found something startling: patterns of damage and interrupted growth that looked eerily similar to the bone lesions found in animals that hibernate. This led to a mind-blowing hypothesis. Could some early humans have survived the most brutal parts of winter by hibernating? The idea is that with food impossibly scarce, these hominins might have dramatically slowed their metabolisms and entered a state of torpor for months, just like a cave bear. Now, this idea is heavily debated and widely criticized. A human-sized brain demands a huge amount of energy, even in a state of torpor. Whether it was true hibernation or something else entirely, the evidence from that Spanish cave suggests our ancestors may have resorted to strategies so extreme they border on science fiction. It shows the sheer lengths the human body may have gone to just to endure. From the borrowed blueprint of the Neanderthals to the microscopic furnaces of brown fat, from the genetic code we inherited to the wild possibility of winter hibernation, the story of Ice Age survival is written not just in stone tools and cave paintings, but in our very blood and bone. Our ancestors didn't just endure the cold, they internalized it. They rewired their own tropical bodies to become something new. They built a biological survival suit made of specialized fat, tweaked metabolisms, and hacked genetics. Those eternal winters are long gone, but their legacy remains. The genetic echoes of that incredible struggle are still present in the DNA of populations all over the world. We are the descendants of the ultimate survivors, the ones whose bodies found a way to conquer a world of ice.
It's a powerful reminder that beneath our modern lives, we still carry the resilient blueprint of ancestors who stared down an ice age and simply refused to freeze.
What do you think was humanity's most insane adaptation? Let me know in the comments below. And if you enjoyed this, make sure to like and subscribe for more stories about how we got to be who we are.